All right, so welcome to this EnviroSchool session here for the month of May. We are recording this session so that you can watch it later or share it with a friend. And we are so happy that you're here to learn about Michigan's environment and the professionals who do the work to keep our environment safe and healthy here in the state. Today, we are focusing on air quality. It is Air Quality Awareness. I guess last week was Air Quality Awareness Week, and it is Air Quality Clean Air Month. So we really want to focus in on what we can do to protect air quality in the state and what EGLE does to manage that quality. We had the earliest Clean Air Action Alert Day, I think, in our program's history this year on April 14th. So there's a lot going on around air quality that we just really want to understand better and help you understand better so that you can teach about it to your classes. We here at EGLE, for those of you who aren't familiar with us, we are the state's environmental agency, and our mission is to protect Michigan's environment and public health through the management of air, water, land, and energy resources. We do that in a variety of ways. We enforce the state and federal rules that are in place to protect the natural resources and the people of this state. This includes things like enforcing pollution laws or investigating spills or other emergencies. It includes testing drinking water, helping redevelop contaminated sites. Our staff work with partners all across the state and all different types of organizations, whether it's business, industry, government, the public, and we work to reduce or eliminate pollution. So that includes things like monitoring of air quality, like you'll hear today, water quality, drinking water, soils. It includes limiting pollutants through permitting. It includes inspections to make sure that facilities are complying with regulations that apply to them. We do quite a lot of outreach and technical assistance to communities to help the regulated communities understand how to comply and the public to understand how to engage and be active environmental stewards themselves. And we also provide a lot of financial assistance to help construct and upgrade infrastructure in places like water, wastewater, drinking water, brownfields, recycling, and so on. So more than half of our budget actually flows back into the community in forms of loans and grants to help them protect the environment and public health. You probably don't care a ton about our org chart, but just so you get a sense of the types of things that we do and the people who do them, we work with partners at all different levels at the local, regional, state, and federal level. And we have what we call 6 program divisions that focus on air, water, drinking water, materials management, remediation and redevelopment of contaminated sites, and oil, gas, and minerals. And then we have these 4 offices that are more high level, policy level, and then we have our support services. And we have, in our past EnviroSchool sessions this year, covered pretty much all of our program divisions, which is really exciting, including the support services through places like our GIS team that we talked about a couple months ago. And then this month, we are finalizing the 2022-2023 school year of EnviroSchool with focusing on our air quality division. And so I don't know, maybe next year we'll focus in on our program or our offices since we haven't really covered those yet this year. But we have really covered a wide variety of what staff do in our department over the past few months, and we are happy for those of you who are here who've been participating with us in that process. This series is a relatively new venture for Eagle Classroom, and we developed it because we really wanted to help support our educators in teaching about the environment, make sure that they feel comfortable and they understand the content that they're teaching. We also wanted to help create connections between those educators and professionals in the field so that when they or their students have questions about what careers are out there, they have some reference of what people do and what those jobs might look like. And that connects back to our career series, which I'll mention a little bit later at the end of the presentation. And we also just want to really promote our mission of protecting the environment and public health by helping people, the general public, educators, students understand what they can do to be a part of protecting Michigan's environment in a variety of ways. So today's presentation, some of you have been on here before, some of you, this is your first EnviroSchool webinar. So the way these are structured is we will have 45, 50 minutes or so of presentation from our wonderful presenters. And we will then have a more unstructured question and answer time at the end where you can interact with them directly if you have questions that you want to ask. And that can happen through the chat, or that can happen through raising your hand and unmuting at that point in the presentation. So I'm going to go ahead and introduce our three wonderful presenters right now. We have Keisha Williams. Keisha is a toxicologist in our air toxics unit. We have Erica Wolf, who is a quality assurance manager in our air monitoring unit. And then we have Alec Konacki, who is one of our meteorologists and helps produce the state implementation plan. So they have a wonderful set of resources ready and waiting for you. And without further ado, I am going to go ahead and hand it off to Keisha.
Thank you so much, Eileen.
You should have
If
control now, Keisha.
perfect. And if I could ask you to launch the poll before going more into the presentation, um, we want to learn a little bit more about you all. And so we have a poll to do that. And the question in general is, when did you first become aware that air quality is important and something that should be monitored? It might have been when you were a young child, as a student, you might have learned about it in school. Um, as an adult, you might have learned about it. Um, you may have learned about it, but in your experience, air quality isn't that big of a deal. We're interested in folks' opinions that way as well. And you may just be learning about it tonight. So if you can go ahead and fill out that poll. And so I'm seeing a lot of folks learned about air quality as a young child, some folks in school, and some folks as adults. That's a really awesome kind of variety of folks who have learned about it in different parts of our lives. Thanks for filling out that poll. Okay. And our presentation again is called Clearing the Air. We're really focusing on air monitoring, but as you'll see, based off of our program, modeling also becomes really important to discuss. So we'll cover that as well. Okay. So as Eileen mentioned, I'm Keisha and I'm a toxicologist. I get to work with the Air Quality Division, or AQD as we refer to it, with really a focus on air monitoring from a health perspective as a toxicologist. With that, we're going to start off with a couple of examples with that in mind, looking at air monitoring and why it's specifically important from a health perspective. And so with that, our first example is related to environmental emergencies. And so if you remember back earlier this year, there was unfortunately an example where a train derailed in Ohio, and there were large plumes, large amounts of smoke. There was a chemical spill, and with that, nearby residents had a lot of concerns, a lot of questions in terms of how might this impact their health, what do smells, what does that indicate about what they're being exposed to? And so air monitoring helps us start to answer a lot of those questions in terms of what chemicals might people be exposed to, how much of a given chemical someone might be exposed to, as well as how long someone might be breathing in a given chemical. And so it really becomes important. And those environmental emergencies are pretty obvious examples of where air monitoring is helpful. Outside of environmental emergencies, we have learned over the years that air monitoring can give us a lot of valuable information about air quality. Another example that we'll go more into is related to particulate matter. And so we call it particulate matter. Another um, abbreviation that we'll use is PM or particles. And this type of pollution is an important example because it has been shown to be a major health risk driver. Um, Particulate matter or PM, another way to think of it is really, really small dust or soot that's in the air that can be so small that we typically can't see it with our naked eye. But based off of research and monitoring that has occurred, we now have national standards that have been developed based off of the size of a given group of particulate matter. And based off of the size, we know that there can be a certain amount of toxicity associated with PM. We refer to these national standards as National Ambient Air Quality Standards, or NAAQS, and you'll often hear us also refer to those as NAAQS. And so over the years, there have been National Ambient Air Quality Standards, or NAAQS, for total suspended particulates, or TSP, as well as subgroups within kind of that total suspended particulate group. Going more into those subgroups, there are two that we really focus on that have national standards. And this picture is going to help us kind of put that in perspective in terms of things that we're more used to, like a strand of human hair or a few grains of a sand. And so when we think about particulate matter that has a diameter of 10 microns or less, we call that PM10. And that subgroup is much smaller than a grain of sand. It's much smaller than the diameter of a human hair. Within that subgroup, there's another smaller subgroup called PM 2.5, which is particulate matter that is 2.5 microns in diameter or less. This graph is modified from one that is presented in our annual air monitoring report. It's a little complicated, so we'll go through it slowly. On the y-axis, we have PM concentration, or the amount in micrograms per cubic meter. On the x-axis, we have the year that the air was sampled and that we got measurements for PM. This is showing long-term trends at a specific site in Detroit, and it's showing it for essentially, I would say, three main kind of take-home messages with this graph. One, it's showing us the annual averages for PM for a given year. Two, it's showing us the different size fractions of PM that have been measured over the years at that site. And three, it's showing that information of the measurements as compared to the health-based uh, NACs. And so, for example, we have TSP, or total suspended particulate measurements, in these earlier years as compared to the TSP health-based NACs. And here we have um, the PM10 measurements at this site as compared to the PM10 NACs. And here we have the PM 2.5 measurements as compared to the PM 2.5 NACs. So I want to point out that at this particular site, TSP and PM10 continued to be measured, but this site is really focusing on the measurements for a given PM size fraction at the same time that its corresponding health-based standard was in effect. And so I'll explain that more in terms of the health context of the National Ambient Air Quality Standards that we're looking at. So in the 1970s and in the 1980s, when the National Ambient Air Quality Standards for TSP were in effect, there was little information about uh, the health effects of particles on the body. But by the early 1990s, we had a better understanding, and there was more research that showed that PM10 specifically could have a adverse health effect in the lungs. And so, with that, the TSP NACs was replaced by the PM10 NACs. By the kind of late 1990s, we had more information that suggested that an even smaller fraction, PM2.5, could have adverse health effects in terms of worsening heart conditions as well as causing premature death. And so, with those, with that additional information, then uh, NACs, or National Ambient Air Quality Standards for PM 2.5, were adopted. So again, this is looking at 50 years worth of data and summarizing that within this trend chart. We see a couple of things. We see that as um, over the years that the air quality is improving in terms of PM, and that the air quality is getting better in that regard. At the same time, we're seeing that as we learn more, as there's more research, and as we understand more, that we're understanding that the potential, we're understanding more about the potential health risk and the health effects of particles. It's really driving the standards to become more health protective. And in fact, earlier this year, the federal government recommended and proposed for strengthening of the PM 2.5 NACs to be more health protective. And I wanted to point out one thing. Although we often talk about particles as one group, particles come from many different sources. And so, with that, it's also really important to think about them in terms of a complex mixture. And here are just a few examples of different sources. There may be particles from transportation, so car exhaust. There may be particles from power plants or industrial sources. And so, again, although we talk about them in terms of one group, when we think about PM 2.5 specifically, it's still a complex mixture. They just so happen to be the same size particle. In 2017, there was an estimate of the outdoor air emissions for PM 2.5. And with that, here we see what that breaks down to in terms of the major sources and percentages from these different emission sources. So we see that major sources are fuel burning, for example, um, dust that just might be flying around. Industrial sources are major sources of PM 2.5. And specifically, this was an estimate of sources in Michigan. And I also want to take note that with this, we're focusing on outdoor air sources. So um, there can be outdoor air quality issues, but there can also be indoor air quality issues. Specifically here, we're talking about outdoor air. And so, although there can be indoor air quality issues, there can be outdoor air quality issues, there can be PM 2.5 emission sources from a number of sources. Michigan's Air Quality Division specifically regulates and specifically controls for a select number of sources. And so we have authority to look at just a certain number of really important sources. And those are sources like industrial sources, like waste disposal sources. So, for example, landfills are ones that we can control so that we can protect public health and the environment. And so now we're going to transition a little bit more into how we do that as the Air Quality Division. And here's a diagram that focuses on the major kind of programs within our division. Two of the main programs that we have are related to air permitting and air monitoring. With air permitting, we require that when a facility operator is planning to add or change a method that will emit to the outdoor air, that they are required to get an air permit. And so with that, um, that allows us to make sure that that we review the emissions that are being proposed to be emitted, that we make sure that they meet all of our rules and laws. And then to support that program, there are a number of other kind of pieces that are considered. And so that might include reporting requirements where facility operators must keep records to make sure that they're complying with that permit. There are inspections to inspect a given facility to make sure that they're complying with a permit. If needed, there are enforcement actions that can be taken if the permit was not being complied with. And there may also be on-site or fence line monitoring where it helps us understand whether or not the permit is being complied with. So that's looking in general into the air permitting program. The other aspect of it, as we're looking forward to talking about more today, is looking at the statewide ambient air monitoring program. And so with that, we're measuring different pollutants at specific sites around the state and measuring those levels, especially to make sure that it can inform our state planning process. And state planning is where, if for a given pollutant, the levels are not meeting the national standards, our state planning process allows us to use specific pollution reduction strategies so that we are then again meeting the national standards. So for this presentation, of course, we're focusing in on air monitoring. But our air permitting process is interesting in that it's very proactive, where um, it's looking at proposed and predicted emissions such that the emissions haven't been released so that we can monitor them. And so with that, we use air modeling. And so we'll again be talking about those two main pieces of air permitting, especially focusing on modeling, and the statewide ambient air monitoring network. Of course, there are exceptions where there may be modeling that's done for the state planning process, for example, or there may be monitoring that's done outside of our statewide ambient air monitoring network, but those are going to be the main two pieces that we focus on. First, we're going to get started with looking at the statewide ambient air monitoring network, and Erica is going to lead us through that information.
Thanks, Keisha. While we're switching control here, I guess I'll reintroduce myself. My name's Erica Wolf, and I am in the in the air monitoring section. And this is interesting. I'm seeing a blank screen. Oh, there we go. I went to school at Oakland University, and I ended up in our air monitoring section about 20 years ago, and now I'm the quality assurance manager for the section. But today, before we get into what we monitor and where we monitor, I want to go through what ambient air is. Now, ambient air is what we monitor, but it is different than what you might think. There is actually a definition of it, and it is air that's accessible to the general public. This is outside of neighborhoods, schools, parks, and outside of the fence line of an industry property. So anything that the public could access. And we monitor it for a couple different reasons. The first is we are required to provide data to the public in a timely manner of their general air quality. We also have to comply with different EPA regulations that require specific types of air monitoring. And lastly, we monitor to provide support for research studies. So moving on to some pollutants that we do monitor. First and foremost are the NACs, or as I labeled it here, criteria pollutants. Those are carbon monoxide, nitrogen dioxide, sulfur dioxide, ozone, lead, and particulate matter 10 microns or less and 2.5 microns or less. These, again, are the ones that EPA has health-based standards for, and that is first and foremost what we monitor for throughout the state. Secondly, we also monitor for a host of other air toxics, metals, and meteorological data. Now, some of these, like VOCs or volatile organic compounds listed at the top, they actually contribute to ozone production, and ozone being a criteria pollutant. Carbonyls and polyaromatic hydrocarbons can be have potential cancerous health effects. Polyaromatic hydrocarbons, it's a group of over 100 different chemicals that are formed during incomplete combustion. We measure for certain types of metals and PM2.5 speciation, like Keisha talked about PM2.5 being created in the atmosphere from various other, from a bunch of different sources. We measure that at certain sites to figure out what sources contributed to specific PM2.5 particles at the site. And the meteorological data, we try to measure that at most sites, and this helps us really hone in on where pollutant plumes might be coming from or going towards. So now let's focus in on where we actually monitor in Michigan, with starting with how we choose our monitoring locations. Again, we have a lot of requirements we have to comply with when we choose a monitoring location. The EPA sets out standards based on what type of pollutant we need to monitor, how many monitors we have to have for each pollutant, and where those need to go. And our funding is directly tied to the EPA requirements. Therefore, almost all of our monitoring locations do follow those regulations. A lot of the requirements are population based. So that is usually the first thing that we look at, where is the highest population. And then for certain types of monitors, for picking different monitor locations, we always look at the expected highest pollutant concentration and the predominant wind direction. In addition to that, we try to pick places that are where people might congregate outside, such as schools, like playgrounds, or parks. Because our monitoring requirements are directly tied to, because our funding is directly tied to the monitoring requirements, most of our pollutants that we do monitor throughout the state are ozone and PM2.5, because those are the ones that EPA requires the most monitoring for. So I am going to, in a few minutes, walk you through our air monitoring sites throughout the state, but just because there happens to be an air monitoring site somewhere doesn't mean that it monitors everything that we monitor for throughout the state. It could only be an ozone only monitoring site. So this slide is showing a few things. First, there is an interactive web map that I'm going to take you to but this slide itself is showing where all our monitors are throughout the state and where schools are located in relation to those monitors if they're within 3-mile distance. So the purple points are the state air monitoring sites. The blue point is the tribal air monitoring site that is within our air monitoring network. The green points, those are, and my head is circling the green point here so you know what I'm talking about. Those are sites that are located at schools. We currently have 4 sites at schools. And then you may see some little halos beyond the purple dots, and that means that there are schools nearby those sites. I'm going to switch. Wrong page. Oh dear. What did I do?
You could just stop sharing. So just reshare.
Okay, thank you.
No problem.
Okay, so I was trying to save time and look what happened. So here is our interactive map that's available on our website. Each of these dots is one of our air monitoring sites. You click the dot and it shows you the site name. And I know you can't read this right now, but you can go to it later if you want. The site name, the address, a link to our air monitoring website, a link to the monitor photo. Like this is one that is at Otisville. And then a link to real-time data for that photo, for that air monitor location. And this was Otisville earlier today when I pulled up the data. I do apologize. Eileen, could you reshare?
Yep. Sorry about that. I forgot it was on my screen.
No, that was my bad.
All right.
Okay.
Make
So,
sure I give you
and
control. Oh, there you go. Sorry.
and that
Had to give you
map
control.
on, that's okay. That map online does look a little different than the one on the screen because the one on the screen is overlaying schools on top of the sites. And I just wanted to zoom in a little bit on that so you could see, like, this is the Detroit, Lansing, Flint, Saginaw area, and there are quite a few schools within 3 miles of an air monitoring site. And you could use that interactive map online to find out where your school is in relation to a site. And another thing that Eileen will probably talk about later is if anybody has any interest in incorporating a visit to an air monitoring site into their curriculum, please reach out to Eileen. We can try to work that out. Next, I'm going to just walk you through a few things on our website. This is like the top page of our website. It's a screenshot of it. And you'll see the interactive web map and then reports next to it. A few things to highlight from here are nice. Technical difficulties. Okay. Go back, go back. There we go. Annual air quality reports. This is a report that summarizes every single data point we collect for the previous year. We are working on putting out a 2/3 complete version of that over the next month, and then we'll be adding our air toxics information to that a little later this year. The next point is below it. It's our annual air monitoring reviews. This is what we call our network plan. This is required by EPA, and we put it out for public comment every year, and it describes what we're planning on monitoring and where we're planning on monitoring for the next year. This has to go out to public comment for 30 days, and our one for 2024 will be out for public comment towards the end of this month. And then after the comments are received, we incorporate those, review it, and send it on to EPA. If you're interested in signing up for getting that notification, you can go to the Air Quality Public Notice webpage and sign up for that. Now, towards the bottom of our webpage, we have 3 columns. The first column is air monitoring resources. And on this, I just wanted to mention that the air quality forecast. Now, this is something that Alec and our other meteorologists contribute to. This is completed every 1 to 2 weeks, and it discusses details of forecasts statewide with emphasis on particulate matter and ozone pollution. In the middle, we have our special monitoring projects. Some of these are completed, some of these are still in the middle of the monitoring for them. And the last column is, how is my air quality? First tab under that is real-time air quality information. That links you back to the page that I showed before, which I'm a little too scared to screen share and move again, but it shows you the continuous data from our monitors that have continuous data throughout the state. And then we have a Get Notified, Sign Up for Air Quality Notifications tab. This allows you to sign up for daily notifications if you want to get the air quality index directly to your email or text. Now, what is the air quality index, you might ask? Well, that's the next slide. The air quality index, this is created by EPA to comply with the statutory requirement that we report information to the public in a timely manner about their air quality. It is a numbered system and a colored system. Green is good, yellow moderate, and it goes all the way up to hazardous or maroon. In Michigan, we're usually in the green or moderate range most of the time. Now, the index number, or the AQI number, for green is 0 to 50. And for yellow, it's 51 to 100. Now, these numbers and the information that goes into making these numbers, as I said, it's a daily number, it's a daily index. The information comes directly from our continuous air monitors, from our ozone monitors and our PM2.5 monitors. And if you look at the real-time air quality data, the numbers from the monitors will look different than the air quality index number. And that is intentional because the air quality index really melds the two together. So they're not going to be the same, but they do draw from our air monitors throughout the state. So now I'm going to move into how we actually monitor the air. So I showed you the picture of what one air monitoring site looks like, and this is pretty much what a lot of our sites look like. They're a big cube surrounded by a fence, and all the fun equipment is inside, and there's a few inlets outside that help draw the air into the equipment on the inside. Some of these may only have one monitor inside. Some of them might have 5 or 6. It just depends on where they are throughout the state and what the requirements are for monitoring at that location. Other air monitors are just standalone monitors. And like this one, for instance, it's a manual method monitor. So this would not be reported to the air quality index, even though it is a PM 2.5 monitor. It is a manual method, not continuous, so it can't go into the air quality index. So here's a close-up of some of our measuring devices that we use. Over on the picture with the decking, you will see a lot of our different manual method monitors. The one in the front here is a PM 2.5 monitor, and the one all the way in the back is a lead monitor, which those used to be used, or something similar to that used to be used for measuring TSP, or total suspended particulate. The picture in the middle here shows some of our ozone machines. The ozone analyzer is on the bottom, and that's what actually gets the real-time ozone data. And the picture next to that shows our continuous PM monitor that measures PM 2.5 and PM 10. And lastly, I want to touch on, well, I want to say before I move on to sensors, that these are considered, everything on this page and up till now, what I've been talking about, are regulatory monitors. They are there to monitor the air and comply with our regulatory requirements per EPA, and the methods that they use to monitor also comply with EPA requirements and are considered federal reference methods. Reference methods. So on to sensors. Sensors, which one is pictured here, and I have one right here to show you the scale. They are very small, which is great. They are inexpensive. You can use a lot of these to cover large areas. The problem with sensors is they can and do over or underestimate different values. They are not, the technology just isn't there to make it great to either put into the air quality index or use to really satisfy the EPA requirements to say that the PM 2.5 level is at whatever the sensor level is showing. Now, this monitor that I held up is one of the purple air monitors. These are the ones that our section is utilizing right now. We have a couple we have started to deploy, and this top is the purple air map link to their website. This website shows every monitor that is currently reporting to the Purple Air network. And here is Michigan. For example, you'll see that they look fairly similar and they're good for informational purposes. And we have a few that we're starting to deploy to kind of fill in gaps in our network. Now, we also have the EGLE Classroom program, which has some of the clarity monitors for clarity movement monitors for use that can be lent out. And then EPA has created a fire and smoke map. And that is interesting because it integrates both sensor data and regulatory air monitoring data throughout the country, but it's really used more towards areas that are more prone towards smoke issues. And with that, I will give it back to Keisha.
Perfect. Thank you so much, Erica. Um, we're going to now transition and talk about the other um, major area of our program with permitting. And I'll go back to the diagram really quickly. We'll revisit this of, we just talked about air monitoring. And here we'll transition to air permitting with modeling. And with that, I'll give it to Alec.
All right. Do I have control yet, Eileen?
I think you need to request it.
Oh, that's right. Yep.
All right, you should be all set.
All right. There we go. Okay. How to figure out where to advance the slides. So why do we model? So it was touched on earlier on in the presentation by Keisha. Basically, if a facility or anyone in the state that needs to pull a air permit for any changes in processes that they're doing at their facility that will have increases in pollutant emissions, or in some cases decreases. We've had applications where they're actually decreasing, but there's some other technicalities where they still need to pull an air permit. It goes through our permit engineering staff, and they are the ones that deem that it needs modeling. And if it needs modeling, it comes to us, me and the two other meteorologists within the AQD and within EGLE. So basically, we use modeling to present emissions from the facility at any given point based on receptors, which I'll get into 2 slides from now. And the model that we use is called AirMod, and it is the gold standard model agreed upon by EPA and the American Meteorological Society. So basically, where do we model? And this was touched on by Erica. So we model the ambient air, which is the portion of the atmosphere external to buildings to which the public has general access to. So as you can see in the picture on the right here, there's a fence line with barbed wire. And within this fence, this is deemed as industrial or facility areas or property to which the general public does not have access to. So we do not model for those areas. But right on the outside of the fence here, you can go up right up to the fence, put your fingers through it, look in. That's where we model at. That is deemed as the ambient air to where we model for. And the picture on the left here, this is down in Detroit, and the Southwest Detroit monitor is right here in red. And again, I'll get into all these little red dots here in a minute. But I just want to point to right here down along the riverfront. That's all industrial areas and property, so that's where we don't model. But right up against it, all around the border of it, that's where we model for and look at. There we go. Okay. Technology. So basically, modeling also provides virtual monitors, which are receptors, which is what I just mentioned a minute ago. So in the picture on the right here, all these little red dots, these are what we call receptors, which are basically virtual monitors. So basically, these help fill in the gaps to where monitors can't be, or monitors aren't, because monitors can't be everywhere. So also, like I said in the last slide, here is, I believe it's called Zug Island, which is a very industrial area, part of Detroit. This is where receptors aren't within, because this is where we deem the general public does not have access to. But all around it, all around the fence line, and even into the river on the American side, this is where we have monitors at. And I think, yeah, I have zoomed in right here just to show right at the fence line here. This is where we put our receptors at, just to get the accurate measurements of these pollutants and their emissions coming from their industrial processes. So from that, modeling provides pollutant impact information. So as like I mentioned before, this is the Southwest Detroit monitor. I'm not too sure. I always forget which pollutants it monitors. I believe Erica probably knows what it monitors. But from those receptors all around this area, it creates this contour plot with these green shaded areas. And this is what the pollutants are looking like in that area. I'm not too sure what this application was looking at, but I just wanted to include this to show the output from the model that we get. So as you can see, higher concentration is up here, and then lower concentration is in the green all around these areas. So I just really wanted to point out that although the monitor is here, those receptors help fill in the gaps for modeling and monitoring of pollutants and concentrations. So this is going into more of the weeds of what goes into the model. So stack parameters is one of the main portions of modeling because that is what where the pollutants are actually coming out of. So what goes into stack parameters are the emission rate of the pollutants. Each pollutant that is being modeled for can have different emission rates. Each stack within the facility, which is modeling for the same pollutant, can have different emission rates. That is usually decided from either a consultant or the facility or our own permit engineering staff. They do calculations which help tell us what those emission rates are so we can put them into the model. So stack height is a major role, and it goes into my next slide here with building wake. But basically stack height, the higher it is up in the atmosphere, the easier it is for the pollutants to disperse and be lofted into the atmosphere. And then we have temperature, which plays a role as well with the dispersion of the pollutants. We have stack diameter and flow rate, which actually kind of go hand in hand, because if you have a more narrow diameter, the flow rate will be faster. Whereas if you have a wider diameter, the flow rate will be slower. In those cases, we usually have the stack height be raised so that the pollutant can be dispersed into the atmosphere easier. Then stack orientation is just detailing whether it's a vertical stack, like these 4 stacks here, or a horizontal stack where it's pushed out and then dispersed into the atmosphere. So like I just mentioned, building wake is basically where you have pollutants are being released near buildings, and those buildings create turbulence and eddies for these pollutants to be trapped in and create little swirls and not really disperse as they really should. So this is where stack height plays a role. So AirMod does a pretty good job with modeling areas that have building wake effects and tell us if either the flow rate needs to be increased, so it speeds up more to the atmosphere to disperse, or if the stack height just needs to be increased so it can be lofted into the atmosphere easier. So you can see in this little 3D model, the white smoke is just being played around and impacted with the buildings. So in this case, we honestly would probably just ask the consultant or facility to raise the stack a couple feet. So yeah, like I just said, the emissions released in proximity to buildings need to be considered with modeling, which AirMod does pretty well. It is pretty interesting to see within the model and the output files of some heavier concentrations of pollutants in areas where if you don't really look into it as much, you're like, what's going on here? But if you see the proximity of the buildings, it kind of makes sense because like a building is blocking the pollutant from dispersing more. And also with modeling meteorology, I'm a meteorologist, so I love this stuff. We have roughly 70 meteorological stations around the state. Like Erica mentioned, some of the monitors that we have meteorological stations on them. So basically those look at wind speed, wind direction, temperature, precipitation. We get upper air data from local and National Weather Service offices in Detroit, Gaylord, and Green Bay, Wisconsin. Grand Rapids, that office does not do upper air balloon launches. And then surface features plays a role too. And then representativeness. So basically to describe what representativeness is really easier just by explaining an example. So say we have a facility in northern Michigan, it's more inland, maybe near the Gaylord area, and the closest monitor is on Lake Michigan. You can't really compare those 2 areas because one is along the lake, which traditionally has more wind, it's a little breezier and cooler because it's closer to the water. So we wouldn't really want to use that meteorological data for the facility more inland because it's not really representative of the facility. So what we would do in that scenario is maybe go with the second closest monitor, and that's more inland, and use that because it's more representative of the area, just so we're able to get the most accurate meteorological data and the most accurate concentrations and emissions from that facility. And also, terrain features play a pretty big role, or can play a pretty big role in modeling. This is a good example. Although I'm a Michigan fan, this is a good example here in East Lansing. I believe this is on State's campus. So valleys can pool pollutants into an area. We see this a lot out west with the mountains and valleys. A really good example is in Salt Lake. It's in a big valley, and pollutants are typically more dense. So they like to pool in areas to where there's not really not much dispersion, and just kind of sit there until they get blown out by prevailing winds. And also terrain features like hills or mountains can act as a wall to pollutants and restrict them from dispersing into the atmosphere. We don't really see this too much in Michigan. We're pretty flat here, but although I did have an application about a year and a half ago in the Upper Peninsula, it was 3 portable asphalt plants on the western portion of the UP. They're the same pollutants being modeled, identical setup. They're just honestly just in different locations. One was in the southern western UP, the central western UP, and then the northern western UP. The southern and central western UP locations were fine. They're more so in forested areas and flat areas. But the the northern western UP location had some terrain features, some hills and some mountains up there, to where I noticed on the modeling output that some pollutants and concentrations were being pooled in some areas and misdirected to some areas where you wouldn't really expect. But if you looked at terrain, you would see that there are some features there that were kind of not allowing it to disperse. Those applications passed, so it wasn't anything to worry about. But it was just interesting to see that Michigan actually can have some terrain features that play with pollutants. All right, now I'm going to run through a quick AirMod interface of a hospital up in Marquette, Michigan. The pollutant that I'm going to look at was beryllium, and the averaging times were 24-hour and annual. And those are basically just the averaging time to which we look at specific values for the pollutant. And this pollutant passed, so shouldn't raise any concern. But I just wanted to show everyone what exactly goes into AirMod. So quickly before I start, I just want to make sure if everyone can see my screen.
Yep, it looks good.
All right, cool. So this is AirMod, the gold standard. As you can see here, this is the hospital. I had to build this. Basically just drag and drop some preset buildings you have over here on the left. And also you can drag a line and trace an object within AirMod to create these buildings. And if we zoom in more, these 3 plus signs or crosshairs, they're basically the boilers that we're modeling for. And they're on top of the hospital roof. And if we zoom out, wrong way. These green plus signs, these are the receptors. So as you can see, it was deemed around this hospital, the general public should not have access to it. There's a fence around it. So we did not put any receptors around here. But right up against the fence, all around here, we call these fence line receptors. We put those there because that is where the general public has access to. And as you can see too, if you zoom out more, right around, more specifically around the hospital, it's a denser grid for receptors, because that is typically where we see the higher concentration of pollutants before it gets lofted and dispersed into the atmosphere. And if we zoom out more, you see a little bit, you can see it's a little hard to see, but you can still see some of the green plus signs and the receptors and how far out it goes. So I'll go through in more detail of what we actually do with setting up the model. So this is the control pathway. Typically, we just use this to list the pollutant that we're modeling for. Here's all the different averaging time options. Like I said, this is 24-hour and annual. But other than that, that's basically all that we use this pathway for in this instance. This is the nitty-gritty source pathway. This is the specific location of the boilers or stacks. This is the elevation, which is just from the terrain files that we pull in. And then this is the stack height, the emission rate. This is in pound per hour or grams per second. I typically just like doing pound per hour. The temperature of the stack, the diameter, and then these are the flow rates and exit velocities, which they kind of go hand in hand. If you change one, AirMod does some calculations to figure out the other. And like I said, these were pretty identical. Just the difference was the location of them. So that was the source pathway. And the receptor pathway is where we build the receptor grid. So as you can see, there's a lot of different options to make a receptor grid. This is kind of more so modeler discretion. Each modeler can have their own likes and wants for a receptor grid, but as long as it has a close network of receptors immediately around the facility, and then kind of disperses as it gets farther away, then it checks all the boxes. But there's multiple different ways you can do it. Then the meteorological pathway, this is where we input data from meteorological stations. This was a year and a half to 2 years ago. So this is from 2020 meteorological data. I believe this was an airport, one of the closer airports to Marquette that we used. So we just input the surface data, and this is more so the upper air data we import. Then the output, this is where we just kind of create some of the contour plots, make sure the sum file, which gives you the output data, is all good and correct. And then the terrain, like I said, this is where we just import from basically the web from the USGS website to give the overall terrain. And then for the building pathway, I don't really look at this too much because you're able to basically get this screen by building the model right here on the left side, like I mentioned. What I like to do is just import some heights that are more specific. So after this is all done, we go up to run here. We verify the error mod run, which is basically just it checks everything, make sure there's no errors, there's no bugs, and kind of the save as feature. Then we go to run error mod, sets it all up. Won't run it because it might take a minute. And then we go down here, it's run, and this is the final, wrong way, final output for the error mod model. So this is for the 24-hour output. So as you can see, most of the concentration here is confined to right by the fence line and closest to the facility that it disperses as it goes more north. So this is the annual, kind of the same thing. It's more of a time frame, so it goes out a little bit more, but it's more confined to closest to the facility. And both of these passed our regulations, I believe, for the 24-hour. The measurement we got, I wrote these down just so I didn't forget. The measurement we got was 0.00231 micrograms per cubic meter. That's the metric and measurement that we use. And then basically the passing value for that is a 0.02, so it's way below. And then for annual, this one came out to be 0.00068 micrograms per cubic meter, and the passing value is 0.004. So like I said, both of these passed, but yeah, I just want to give a brief overview of what we actually do within the AirMod model. So I'll stop sharing and have Eileen take back over.
Okay, wonderful. Thank you so much for that, Alec. That was really interesting to see how the model works. All right, so those are some wonderful presentations from our presenters. Really happy that we could have such great information about how we monitor the air, what we're monitoring. I'm going to open up to questions in just a minute, but I'm going to quick drop in the chat. If you are an educator who wants to earn sketch credit in the state of Michigan for participating in this webinar today, you can complete this form at some point between now and the next week or so to let us know your PIC number and eh, um, your name and everything so that we can get you the credit. This is also just a general survey. So if you're not an educator and want to give feedback on the session, we really welcome your feedback through there as well. So please go ahead and complete the survey, and you can skip the parts about being an educator if that doesn't apply to you. So we're going to just quickly wrap up with talking about some resources for you if you want to take this back to your classroom, or if you want to take it to a community group or another group that you educate or do outreach to. So all of this is like a long list of stuff you're seeing on your screen right now. All of these resources will be sent out in a follow-up email that will come within the next few days once we get the video processed and up on our YouTube channel. So it should be a couple days, you'll get a follow-up email from me with all this information and a recording that you can share with others or you can watch later. But we have a lot of great resources that you can take back to educate with. So as Erica mentioned earlier, there is the air monitoring website where you can pull all kinds of different data. And if you were with us in March and you enjoyed our GIS webinar learning about open maps and data on our portal. You can also access some data through our maps and data portal, and some applications that you can interact with. The website here is going to be the mirror of what Erica showed you earlier to look at our air monitoring information. And we highly encourage you to sign up for notices if you're interested in getting engaged and having a voice in your own community, your own air quality. Sign up for public notices and sign up to get notified about air quality notification so that you know if you have an air cleaner action day in your area. The video I mentioned about air quality instruments is linked on this slide. I'll share that out with you. It's probably like 3 or 4 minutes long video that goes through some of the details about what air monitoring instruments there are and what they monitor and kind of how they work. So it's a really neat introductory thing to share with your audiences if you want to just get a sense for what those sensors, the regulatory sensors look like that we use. And like Erica said, if you are located near one of our monitoring stations, whether it's on a school property or maybe you are with a school who's near or a group who's near, and you want to just have somebody come and tell you what they're monitoring, how it works, please feel free to reach out to me. You'll have my contact information and we can get you connected with one of our technicians who works at that monitoring station near you, and they can meet you out there and they can talk through what kinds of instruments they have, what's being monitored, because as Erica said, not everything is monitored at every site. So it's a little bit different in every location. And if you're a teacher or a school who's interested in accessing air quality data that you could use in your classroom, definitely reach out as well, because we've been working with some partners to develop some resources on how you can use local data in your own community. If you want to borrow a sensor, those are available for you to borrow. So as mentioned, as Keisha mentioned, EGLE Classroom has sensors that are available for you to borrow. They are called air beam sensors, and they look at PM 2.5 and PM 10. There is also the purple air sensor, which is available through some of our library loan programs in rural areas of Michigan. And so EPA has funded our rural library loan program. So there's a few libraries out in the state that have sensors that you can check out as well that are a little bit different than the EGLE Classroom one. And those are listed on our website as well. If you're interested, we have other stuff that you can borrow from our EGLE Classroom program. So I'll send you the link to our website. We've got resources, we've got lessons and curriculum. So the Michigan Environmental Education Curriculum Support, or MEECS units, have a whole unit on air quality that is available online, and it's linked here, and I'll share that out. We have other topics that are available for you to learn about as well, also listed on our website. And then one of the really cool things that we have going on, as I mentioned at the beginning, is our career series. So if you're working with young people especially, and you really want to help them understand what it looks like to have a career in the environment, whether it's in the realm of air or water or cleanup or information technology. We've been doing some really neat interviews with EGLE staff over the last year to highlight their work, what they do to protect the environment, and kind of how they got to where they are. And so you can hear our staff tell their stories about how they got to the positions that they're in. And so the one that's related to our air quality division is one of our air quality inspectors who's been an inspector for a long time. And she talks about how she became an inspector and what it's like to go into these companies and do the inspections, and what she's learned and what was important in her job. So encourage you to check those out, watch the whole series, share them with young folks in your life who might be interested, because they give you a good sense for what that pathway looks like, and understanding that it's different for everybody. I put this in the chat, but again, if you want to get sketch credit, please make sure that you complete this exit ticket. It's very important because we need your PIC number. And if you're not an educator and you want to give us feedback, we would love also for you to complete the exit ticket and give us some feedback on our event today. Just a quick plug in here for two other professional learning opportunities for educators that are not air related, but I wanted to throw them in here real quick while I had you. One of them is every year the Department of Natural Resources in Michigan runs a week-long PD for educators called the Academy of Natural Resources. There's a couple different strands in that, and one strand is MEECS Week, which is where we will be going through all of our environmental education curriculum and training you in 1 week to do all of it. So that includes air quality. It includes some new resources we're putting together for air quality, but it also includes water, ecosystems, climate change, energy, land use, a lot of really awesome stuff. So this is a really awesome event. It's really fun. It's up at the Ram Center on Higgins Lake in Michigan. So encourage you to sign up for that for Meeks Week. We'd love to see you there. And then the other is kind of a turnabout from AIR, I suppose, is our focus on agriculture and environmental education. So in partnership with the Department of Agriculture and Rural Development, we're putting on a 2-day session for educators on the connections between agriculture and the environment. And that registration just opened for that a couple days ago, and it's pretty limited. So if you're interested in that topic, please go ahead and sign up. It's only $35 for 2 days, so it's a pretty great deal. So those are 2 other professional learning opportunities I want to throw out there. But if you have resources or questions or needs around air quality specifically, let me know, reach out to me, and I'm happy to help support you. All right, with that, I'm going to go ahead and stop our recording, and I'm going to open it up to questions and comments from our audience for folks who have maybe something that they want to ask or talk to our presenters about. So thank you so much for joining us today.